Dear students, today we are going to learn about transformers. A transformer is a device for converting high voltage into low voltage and vice versa. It works on the principle of mutual induction. There are two types of transformers. They are step up transformer and step down transformers. There are two types of winding for a transformer. They are primary and secondary. The windings are done over a laminated iron core. A transformer works only on AC. A step up transformer increases the voltage as it is transferred from primary to secondary. That is, secondary voltage ES will be greater than primary voltage EP. For this purpose, the turns on the secondary is made larger than that on the primary. Current in the secondary IS will be lesser than that on the primary. A step-down transformer decreases the voltage as it is transferred from primary to secondary. That is, secondary voltage ES will be lesser than that of the primary voltage EP. For this purpose, the number of turns in the secondary is made less than that of the primary. Secondary current IS will be larger than the primary current RP. These are the important equations related to transformer. The ratio of number of turns in the primary to number of turns in the secondary is known as turn ratio. It will be a constant K. According to Faraday's law, EP is equal to minus NP into d phi divided by dt. ES is equal to minus NS into n phi divided by dt. Taking their ratio, we get EP divided by ES is equal to NP divided by NS. But according to the law of conservation of energy, the energy transferred has to be the same if we neglect the energy losses. Therefore, power in is equal to the power out. For electric current, we know power is equal to voltage into current. Substituting and rearranging, we get EP divided by ES as equal to IS divided by IP. Therefore, the final equations are EP divided by ES is equal to NP divided by NS. Again, that is equal to IS divided by IP. Efficiency of a transformer eta is equal to output power divided by input power into 100. So it will be eta equal to ESIS divided by EPIP into 100 percentage. We saw the equation for efficiency of a transformer. But all the input energy will not be transferred from the primary to secondary as electrical energy. Therefore, power output will not be exactly equal to power input. Let us check the energy losses in a transformer. First one is copper loss. This is also known as Joule heating loss. We have the equation heat generated H is equal to I square RT, where R is the resistance of the conductor. Therefore, to minimize the energy loss due to heat, the resistance is to be made minimum. For this, thick wires can be used and least resistance and economically viable metals can be used as conductors. Next one is flux loss. In an actual transformer, all the flux of the primary coil may not get connected or linked to the secondary. Therefore, all the energy from the primary will not get transferred to the secondary. This type of loss is termed as the flux loss. This loss can be minimized by winding the coils more closer. Next is eddy current loss. This is the energy loss associated with the iron core of the transformer. Since alternating type of current is flowing through the coil, due to change in direction of the current, eddy current or opposing currents get induced in the core. Energy will be lost in the form of heat due to these eddy currents. This type of energy loss can be minimized by using laminated cores that reduce the eddy currents. Next type of energy loss is hysteresis loss. Due to the reversal of the direction of current, the iron core of the transformer gets magnetized and demagnetized repeatedly. Energy lost during this process is known as hysteresis loss. These losses can be minimized by choosing a material of minimum hysteresis energy loss, that is, least area for hysteresis loop.